So, hello everyone. So, my name is Kimbulapitiya. So, today I'm going to talk about the life cycle of a star. So, let's get started. So, in this topic, I would like to divide my main topic into some subtopics, such as first, I will discuss about the comparison of a star and the human life cycle, then the birth of a star, and then I would like to introduce about different age of a star such as protostar stage, the main sequence stage, and the red giant or supergiant state, and finally I will talk about the burnout and the death of a star. So let's move for the comparison of a star and the human life cycle. So actually the stars are like human, they are born, live and die. So in the figure you will see that there is different stages of human life cycles, and also these different stages have compared to the different stage of a circle, so of a star. So um, here the fetus state we can compare to the protostar stage, and the next level of human life cycle, that's mean infancy through the adulthood, can be compared to the fusion, ignition and the main sequence stage. In the middle stage we can compare to the red giant or supergiant stage, and the old age and death. So this time period we can compare to the white dwarf or black hole. So the most massive stars have the shortest lives. So stars that are 25 to 50 times bigger than that of the sun lives for only a few million years. So star like our sun live for about 10 billion years, and the stars less massive than the sun have even longer lifespans. So let's talk about the birth of a stars. So actually these stars are formed in nebula. So interstellar cloud or dust and gas. So in this stage, mostly star consist of hydrogen. So these times we call as stellar nurseries. So that is very first stage of a star. So these are abounded in the arms of spiral galaxies. So in these stellar nurseries, dense part of these clouds undergo gravitational collapse and compress into a rotating gas globule. So you will see in here you can see here rotating gas globules. So it begins to spin as it shrinks. So let's talk about the protostar stage. So this protostar stage can be compared to the fetus stage of a human. So in this stage, you will see in these times it act two kind of forces, that is force due to the gravity and the force due to the thermal pressure. However, the force due to the gravity is bigger than when they compare to the force of the thermal pressure. So in this stage, the because of gravitational force is very high, so these particles are coming inside to the sphere. So in this stage, temperature starts to increase due to the friction, that is more collision of the molecules. When temperature reaches about 10 million Kelvin, nuclear fusion begins. Nuclear fusion generates the energy for a star. When fusion begins, it's officially considered a star. So here the fusion means combining a lightweight nucleus into a heavy nuclei. So let's talk about the main sequence stage. The protostar is now a stable main sequence star which will remain in this stage for about 10 billion years. After that, the hydrogen fuel is depleted and this star begins to die. So stars live out the majority of their lives in a phase termed as the main sequence, the longest stage of a star. So let's talk about the red giant or the supergiant stage. So actually The red giant or the supergiant stage is depending on the mass of a star. So first in this figure we have stellar nurseries, and then we will talk about the upper part. So that's mean the stars up to 1.5 times the mass of the sun. So these stars become red giant, and then it become planetary nebula, and then it will become a white dwarf or the black dwarf. So this the stars, huge stars, that means from 1.5 to 3 times the mass of a sun. So then they will become a red supergiant and the supernova and then the neutron star. So the giant star, that's mean over 3 times of mass of the sun, will become red supergiant and then become a supernova and then finally they become a black hole. So let's talk about the red giant stage. When a star has burned between 10% and 20% of its hydrogen, its core will to run out of hydrogen fuel. So at this stage, the star is entering the end of its life. So we will see the comparison of the human life, that's the middle stage. So we can compare to the red giant or the supergiant stage. So you will see here, this is our sun. This is the current state of sun. So after the sun become red giant, so that means the sun as a red giant in 5 billion years it's expanding. So the diameter of a star can increase by a factor of 200 while its cooling is translated into the radiation of its radiation. The star is becoming what is called a red giant. So a star has run out of hydrogen in the core to undergo fission. Our sun has used only about 5% of its hydrogen. Stars expand about 10 times bigger and then its cores. Its luminosity increases while the temperature decreases. At this stage, helium fuses to form carbon and the core shrinks. It begins losing its outer layer. So let's talk about the burnout and death. Actually, the fate of a star depends on its mass. All the stars, regardless of the size, run out of fuel, collapse due to the gravity. So you will see the low to average stars become a white dwarf, and the large mass star become neutron star, and the very large star, so they become a black hole. The star will become either a black dwarf, neutron dwarf, or black hole depending on how massive it was. So let's talk about the ultimate fate of a medium mass star. So that's mean star sun-like star up to 1.5 times the mass of the sun. So this kind of star become a red giant, and then they will become a planetary nebula. So what is planetary nebula? So this is left when a red giant loses its outer layer of gas, leaves only the core. The core will finally become a white dwarf. So this is white dwarf. And what is white dwarf? So it's only the hot dense core of this star is left. It will shine for a billion of years before cooling. So you will see this is very old stage of a human life. So it is compared to the white dwarf or a black hole. The stars with no nuclear fuel radiates its leftover heat for billions of years. Finally, it would become a black dwarf. So what is then black dwarf? This is the final stage of a medium-sized star. At this stage, the star is completely dead with no leftover heat. So that means no emission of visible light. However, the universe is not old enough to form this. So let's talk about the ultimate fate of a high mass star. So that means stars from 1.5 to 3 times of the solar mass. So this kind of stars become red giant or red supergiants, and then it will become a supernova and become a neutron star. If the mass is very high, that means over 3 times of mass of our sun, it will become a black hole. So what is supernova? A supergiant star eventually loses its outer layers in an explosion, leaving only the core. This is called supernova. Eventually this core collapses as the iron nuclei are crushed together in this tremendous gravitational collapse. The core temperature rises up to 100 degrees Celsius. If the star's remaining mass is between 1.5 to 3 times the mass of the Sun, it will collapse into a small, dense neutron star. So, the neutron star, what is it? After supernova expansion, the core may condense into a small core of neutrons. It is so dense, so the one spoonful of a neutron star would weigh 100 millions of tons. So you can imagine how mass of this neutron star. So this neutron star spins very rapidly. And finally, so let's talk about the black hole. If the star's remaining mass is greater than 3 times of the mass of the sun, the star contracts tremendously and become a black hole. So this is the most dense core of a star that can be left. So here the gravity is too strong. That means even light rays cannot escape. As a result, it looks like a dark hole in space. So this is the real picture that was obtained very recently. So there's the summary. So we can see this figure. So that's mean so the different stages of a star. So we can compare to the features level to the protostar, and the infancy to the adulthood can be compared to the fusion, ignition, or the main sequence. The middle age can be compared to the red giant or supergiant, and the old state, that's mean white dwarf or the black hole. So depending on the mass, it will become a red giant, or if the mass is very high, it will become a red supergiant. So then it's got the supernova, or the mass is very high, it will become a black hole, and or the neutron star. So thank you for your attention.